Hello student. So today I am studying your next theorem that is called Thevenin Theorem. So Thevenin Theorem, what is Thevenin Theorem? At first I am taking one circuit and then I am explaining how to solve through Thevenin Theorem in any problem. Okay. I am taking one example. This value is 24 volt, like 2, 6, 2 and 4. Okay. That is also ohm, in ohm. So the question is that to find the Thevenin theorem are applicable only for any active network. Okay, though this is only for applicable in active network. So what is active network? Those network which have minimum one sources, that is called active network. Okay, so find the current through the 4 ohm resistance, 4 ohm resistance using Thevenin theorem. Okay, so what is the question? Find the current through the 4 ohm resistance using Thevenin theorem. So at first you start with the question. Find the current through the 4 ohm resistance using Thevenin theorem. Thevenin's problem are solved using 3 steps. Step 1, write down the key point. Step 1 I say that when I am doing step 1, at first write down the key point. Load resistance are open. That means here is only 4 ohm resistance are called load resistance. Okay, this is our load resistance. So load resistance are open. So now I am drawing the circuit. The circuit is like that. Okay, here the load resistance is open. I think you understood. Okay, the value of resistance 2, 6 and 24 volt. Now I am find from step 1 the Thevenin voltage. That is called VTH. This Thevenin voltage also say that the open circuit voltage across the open terminal. Across this open terminal, this is also say that open circuit voltage. So how to find this VTH? Assume this is a A and this is a B point and this is a C and D point. AB point voltage and CD point voltage remain same. This is the open terminal. The open terminal voltage is maximum voltage. So we can say that open terminal voltage, AB point voltage equal to CD point voltage. Why? Because these resistance drop are neglected or not existing. For this circuit, the drop across the 2 ohm resistance are not exist. Why not exist, sir? Because when I am giving the current direction, see, this is a source, the current will flow this direction, coming this point. current are actually divided into two parts, 1 and 2. But here we can see this is the open terminal. That's why no current will flow through this open terminal. The whole current will flow through this circuit or 6 ohm resistance. Whole current will flow through 6 ohm resistance. So if this is a I, then this is also I. There will no current flow. Okay. That's why if I am find I only, then we are able to find the voltage across CD point. And this CD point voltage is also equal the voltage across AB point, and this voltage also equal VTH. Okay. So at first we find the I current. So I is the main current. I equal to V by R. V means 24 by R means these two are connected in series. 6 plus 2, that means 8. 3 ampere. The current flow through the 6 ohm resistance is 3 ampere. Okay. So what is the voltage across the 6 ohm resistance? That means VCD equal to, we can say VCD, this equal to 6 into 3 I into R, 18 volt. This VCD equal to VAB. This terminal voltage and this terminal voltage are same because here no voltage drop will occur across this resistance. Okay. So VAB, this also VTH or VOC. Okay. I think clear. So what is the value of VTH? VTH value is 18 volt. Okay. Okay. Now I am doing the step 2. At first you write down the key point. So what is the key point here? The key point is load resistance open. Load resistance open. Second key point is supply voltage are short circuited. Supply voltage are short circuited. If I am giving any current source, then the current source will be open circuited. Okay, instead of voltage source, if they are present in current source, the current source in this step 2, the current source is open circuited. Clear? So supply voltage are short circuited because this is a voltage source. If your current source will given, then the current source is open circuited. Now draw the picture. So load resistance are open and this is a short circuit. Okay, because this is a voltage source, 2 ohm, 6 ohm. Okay, 2 ohm and 6 ohm. I think clear all of you? Okay. Now I am find RTH. RTH means Thevenin voltage. Now I am find the Thevenin resistance using this circuit. Step 2 circuit, I am find the Thevenin resistance. So how to calculate the Thevenin resistance? This Thevenin resistance is also called R equivalent resistance through this terminal, AB terminal. So at AB terminal, when I am find the R equivalent, what is the way? At first you take one positive and one negative. Okay. Which one is positive? This is a positive and this is a negative. So from positive I am entering the current. From positive I am entering the current. The current will flow this direction assume the current will flow this direction, and here current will be divided in two parts. Now I am calculate the equivalent resistance for this circuit. So how to calculate? I am calculating the back side. Start back side. 2 or 6 connected in parallel. That's why 2 parallel 6 means 2 into 6 divided by 2 plus 6. So 12 by 8. This plus 2, that means 8. 16 plus 12. Sorry, at first I am simplifying. 2, 3, 4, 7 by 2. So what is the value of equivalent resistance? 7 by 2. Now I am find step 3. So what is the value? Actually what I am doing in step 3. So Mr. Thevenin given one circuit which is called Thevenin circuit. This is a one series circuit. This is one series circuit given by Thevenin. Okay, this is a Thevenin circuit. The value of this voltage is VTH, this resistance is RTH, and this resistance is RL. Okay, we know that every value, every element value. Okay, so VTH 18, RTH 7 by 2, and RL is 4 ohm. 4 ohm. Now I am finding the current through the 4 ohm resistance from this circuit. So what actually I am doing? I am converting this circuit into a simplified form. I am converting this whole circuit into this simplified form. So this simplified form given by Thevenin. Okay, Thevenin have given this simplified form circuit. Okay, when I am put those value VTH, RTH, RL, after putting this value, I am find the value of I. So what is the I? I equal to VTH by RL plus RTH, because this resistance, two resistors are connected in what? Series. So what is the value of VTH? 18 by 7 by 2 plus 4, that means 18 into 2 by 8, 15. So when I'm simplified this, 5, 6. So answer is 18 by 5. Oh sorry, 12 by 5. The answer is 12 by 5. I think everyone understood these things. Okay. So now I am start your next topic, Norton Theorem. So how to solve Thevenin Theorem? At first I am taking one circuit, arbitrarily taking one circuit, and from this circuit I am doing step 1, step 2, step 3. How to doing these steps? From first step, load resistance are open. Load resistance open and find the VTH. After finding this VTH, then I am doing step 2. In step 2, the load resistance open and supply voltage are short circuited. If they are current supply, then the supply are open circuited. Okay. Now, from these two conditions, I am doing my circuit. Short circuit, open circuit. Load resistance open, supply are short. From this circuit we get the value of equivalent resistance. So this is the RTH. This is our RTH. Okay. Now I am getting this simplified circuit from this circuit is given by Mr. Thevenin. So Thevenin given this circuit. So I am put the all values and calculate the current through the load resistance. Okay. I think clear all of you. Now I am start your next Norton Theorem. Okay, so now start your next theorem, Norton Theorem. from Norton theorem, when I am applying Norton theorem in any circuit, the circuit must be in active circuit. Okay, must be in active circuit. Okay, suppose I am taking the same circuit and also same value. And doing this through a Norton theorem, the value of this 4 ohm, this is at 2 ohm, 6 ohm, 2 ohm, 24 volt. Now, to solve the Norton theorem, again we need 3 steps. Step 1. So what is step 1? Say that. Step 1 is write down the key point. Load resistance are short circuited. So what is load resistance here? The 4 ohm is a load resistance, because the question is given that find the current flow through the 4 ohm resistance using Norton theorem. So what is this? What is the question? Find the current flow through the 4 ohm resistance using Norton theorem. So here load resistance is called 4 ohm. This is our load resistance RL. So step 1, load resistance are short circuited and find the short circuit current through the short circuit terminal. Okay, so now I am find the current through the short circuit terminal. Okay, so what is the circuit now? From Thevenin theorem, in step 1, this is the open circuit, the load resistance is open, but in Norton theorem, the step 1 is a short, and find the short circuit current, that means ISC. This current is also called Norton current, IN. So how to find? The value is 2, 2 and 6, and this is 24 volt. So how to find ISC? When I am giving the current direction, this is our I current, and when the current is coming this point, the current divided into 2 parts, I1 and I2. But I am seeing that I1 equal to IN or ISC. Okay, so we can say IN, this is a branch current, equal to this equal to I1 also, I1 or IN, anything same, both are same. So IN equal to branch current equal to main current into opposite resistance by sum of resistance. When I am find the I1, the opposite resistance is 6 by sum of resistance. So what is the value of I? Here I means the main current. So how to find the current, main current? I equals to V by V means 24 volt, V by R equivalent. R equivalent. So how to find R equivalent? R equivalent, I am calculating the back side. These two resistors are in parallel, and the resultant will be series with 2. That means 2 parallel 6. That means 2 parallel 6 and the plus with 2. So 2 into 6 by 2 plus 6 plus 2. That means what is the value? 7 by 2. Okay. So the value is 7 by 2. So I equal to 24 into 48 by 7. So the value of I what? 48 by 7. Now I am, so this current is main current. Now I am find the branch current, that means IN, Norton current, not short circuit current. So 48 by 7 into 6 by 8, so 36 by 7. So what is the value of Norton current? This is called 36 by 7. Okay. Now I am doing step 2. From step 2, write down the key point. This is the same as Thevenin theorem. So what is the meaning of same? That means in Thevenin theorem I am find the Thevenin resistance. In Norton theorem I am find the Norton resistance. But the procedure are same. That's why I am write here same as Thevenin theorem. Okay. So what is the procedure? Load resistance are open and supply voltage are shorted. Here you can see that here load resistance are open, supply voltage are shorted, right? 262. So this is the open terminal. From this open terminal I am find Rn. In Norton this is called Rn, in Thevenin this is called RTH. Okay. So what is the value of Rn? Rn equal to 7 by 2. For previous problem we get 7 by 2. Okay. Now in step 3, now I am doing step 3. So what is step 3? In Thevenin theorem I am taking one voltage source and two resistors are connected with the voltage source in series. But in step 3 for Norton theorem I am taking one current source and two resistors are connected in parallel with this. Okay. So what is the value of this current source? This is called IN or ISC. 36 by 7. This is called IN, the value of 36 by 7. Okay. So what is the value of this resistance? This resistance is called Rn, the value of 7 by 2. Okay. And this is a load resistance, Rn, the value of 4. Now I am find the current through the load resistance. The question is given you to find the current through the load resistance using Norton theorem. So now I am find the current through load resistance. That means I current. So I equal to, the main current will divide it in two parts. One is going through load resistance and one is going through Norton resistance. So branch current equal to main current means IN into opposite resistance means Rn by sum of resistance Rn plus RL. Write down the formula because this is a most effective formula. So actually I have consider the current dividing rule only, nothing. Branch current equal to main current into opposite resistance by sum of resistance. Now I am find the IN. What is the value of IN? 7 by 2 into Rn means, and this is a 36 by 2. 36 by 7 into Rn means 7 by 2 into Rn plus RL. Rn plus RL. 1 by 4 plus 7 by 2. 7, 7, 18 into 2 by 15. That means 5, 6 divided by 5. This is the answer. In previous problem, Thevenin theorem, when I am doing the Thevenin theorem, I am getting same answer, that is 12 by 5. Okay, I think understood everyone. So thank you class. This is for all about Norton theorem. Okay.